I want to show you kind of the extensive collection that the museum has and why we're saying this is so important. The museum has just tons of art and artifacts, collections from all different time periods and all over the world. So with that, this is a bowl with peacock motif. This is 13th century. 13th century bowl from Syria. And if you guys have been reading the papers and in the news, I don't know if there's going to be anything left in Syria soon. But it's just incredible if you're looking at this, the 13th century. I mean, where do you find this? You can't go on Amazon and this can't be delivered to you tomorrow. I mean, this is irreplaceable stuff. When I talk about why these are critical facilities and why we need to make sure that we're doing what we're doing, this is the reason why. So everything from the 13th century in Syria to this is even more impressive, right? A plaque from Egypt, circa 1300 BC. I don't even know how you put a date on that, but this kind of stuff you can't find it anywhere. Brooklyn Museum is just an incredible, incredible place. If you ever get the chance to go, highly recommend it. So we have everything from the 13th century to 1300 BC, and then they have some contemporary art. And I know it's early in the morning, and I know you guys, I thank you guys for coming, but I want you to be prepared for the next piece of contemporary art at the Brooklyn Museum, Snoop Dogg. This is an actual piece that's in the Brooklyn Museum. Kind of not my taste. I mean, he's a very handsome man, but hey, listen, something for everybody. So, I'm sorry? Yeah. So, again, irreplaceable stuff, and Snoop Dogg, if you like him, irreplaceable. So, picture of the museum. If you guys have been in New York recently, a lot of amazing projects, ton of work, a lot of cranes all over the place, super tall buildings, glass boxes, right? You don't really find a lot of this stuff, certainly in my area, anymore at all. So we were contacted by the VP of Planning and Architecture with a problem. And this was after all the phase construction. We were also the MEP engineer on this particular job. So we did all the design. And of course, originally they called the designers and said, we have a problem, your design isn't working. Something's not, you had a failure in the design, or it wasn't as expected, and what are you going to do about it? So luckily, smart enough, the designers came to me and said, we have a problem, need you to go do this existing building commissioning. So we talked to the VP of Architecture. We went in, and we started having some interviews before we started the project. And as you can imagine, if you've worked on museums in the past, all we kept hearing, Molly and I, was the museum curator saying, freaking out, right? The art, something's going to happen to the art, and we got to fix this. And all they cared, they must have beepers on their side or something, temperature and humidity out of range. You guys got to fix it, design screwed up, et cetera, right? You probably know what that. So this particular job, like I said, EBCx, sometimes it's about return on investment. Sometimes it's about trying to reduce your utility bill. In this case, it was none of that. It was a clear goal, and like we say in our office, making sure that we're all working off the same sheet music, right? We all had a common goal, and that common goal was to fix the temperature and humidity in those gallery spaces. So it was easy. We didn't have to go through the museum and touch every piece of equipment. It was dedicated to those systems that serve the galleries, and it was a very focused approach. So again, a little bit more of a background. You saw the picture here. In addition to the kind of all the art and artifacts that it has, there's a nice cultural value of the outside of the building, the way it looks. It's kind of the way it sits on the Brooklyn landscape is really impressive. So went through most of this. So again, I know we're in nice, sunny, warm Orlando, but for those of you who aren't too familiar with the area, that's the picture of part of the 5 boroughs, Brooklyn Museum with the Google pointer there. Nice little green area in mostly very urban landscape of Brooklyn. Not a short bike ride to Lower Manhattan, where you'll find the World Trade Center and our office as well. So back in the 1890s or so, kind of this stood alone. The early years, the first part of the Brooklyn Museum, you could see, again, pretty impressive that there's no cabs going through there or anything, just nice greenery and farmland and whatnot. This is early days of Brooklyn. And as we move on in time, you'll see that, you know, the other wings of the museum start to be built. And again, you'll start to see some more urban landscape around it. To the current day, where, you know, tons of apartment buildings and people all over the place, but you could still see it holds its place in Brooklyn, and you have the Prospect Park Zoo, botanical gardens right behind it, really beautiful area of New York. So again, talking about critical facilities and the importance of it, really, really important part of the city. To the current day. This is another picture of the front of it. Again, you're never going to see this much you know, real estate in New York unused or not being able to be leased out to someone, right, for some financial gain. So here's a cut sheet or a portion, a snapshot of one of the air handlers, one of the headered air handling units. In this particular job, we had two variable air volume with return fan air handling units headered together, and a network of VAVs. So again, we talk about those 4 phases over 8 years. It was the air handlers and the first set of VAVs, cap the duct, commission, or not commission everything, but balance it, make sure it's working. Okay, great. Let's come in a couple years later, new set of contractors, new set of CMs, whatever, open that cap up, add a new run of duct, put another couple of VAVs in. You want to touch those other ones? It's not my contract. It was working before, right? Okay, we'll just touch the new ones. Good, cap the duct, next phase, couple years, open up that cap, add another bunch of VAVs. Should we touch the other stuff? You sure it's working? Yeah, it's fine, not my stuff. So whoever did it last probably did a good job. Okay, let's just look at these new ones. And you could kind of see what was going on, especially with the VAVs and all these different galleries. So in addition to the fact that the logistics of the scheduling was a little chaotic, you have the air handling units in the machine rooms on the cellar levels, and then you have galleries of all different sizes, all different locations on the 2nd and 3rd floor, with sensors in all different locations within those galleries, constantly changing, different ceiling heights, right, moving the exhibits all the time. So again, adding to all the challenges that were on this particular job. We're going to come back to this a couple times throughout the presentation, but this is what we walked into. So without really understanding the context of, you know, the X and Y axis here, I imagine the first thing that stands out is it's just really noisy, right? Up and down all over the place, nothing's really controlled. I was in a presentation yesterday with Severio about the healthcare existing building commissioning, and he talks about you never want to see a straight line on a graph, especially in a hospital, right? Because that kind of means you're. But in this particular case, you do want to see a straight line as much as possible, right? We want to maintain a constant level of humidity. You know, practical and realistically, you're never going to really see a straight line, but you'd like to see it a little less noisy than this, right? This is over a couple days, so you kind of get a reference, and this is specifically humidity, right? So we trended a lot of things. We trended temperature, we trended humidity, we trended valve position at the units, we trended return air temperature, return air humidity, et cetera, a lot of things. I don't want to throw everything at you because it's not really important, but this is really what the ultimate goal of was to fix this. So the 4 colors that you see here in all the noisy lines, at least they're kind of noisy in sync here, were the 4 galleries that we were talking about. The Blum Gallery, the Hall of the Americas, the African Gallery, and the Asian Gallery. Those 4 colors represent. The side axis, like we said, is humidity over time. Now that alone, right, that's noisy, not really good. But then when you add where we're supposed to be, the range between 45 and 55% humidity, that's even worse, right? So not only are we not, you know, stable and have more of a straight line, now we're not even in the range, right? We're not even on the field. So this is what we started with. This was the real problem, very focused goal. So I'm going to go through the phases here for existing building commissioning, and then Molly's going to take over. So there's 4 distinct phases, and these are not really shown to the magnitude of which each phase is really supposed to be. The planning phase, right, first thing we do is we start up and we have those interviews with the museum like I talked about. Critical from a couple standpoints, right? You need to develop the information and get all the complaints and issues from the museum's operations staff. But also, extremely important and paramount is to establish a level of trust with those operators, because you're walking into their house, right? You're walking into their house, which they operate and they're in control of. And ultimately, it's everyone in this room's goal to kind of find some issues and fix the problem. Otherwise, they wouldn't have called us in the first place. But how you deliver that information can certainly be different if you don't have a certain level of trust with these guys. So that's first and foremost, and understanding what we have to start with. So the investigation phase is more of what kind of functional testing we talked about, new building commissioning and existing. That's where we're doing the bulk of the actual investigative work, the functional testing. So we're going to put eyes on everything, right? I hope no one in this room kind of commissions from a computer, because I do see a lot of people doing that. I imagine no one in this, again, conference, they're smart enough not to do that. But put eyes on everything, right? The BMS is telling you that a damper's opening, you better make sure that that damper's opening. So that was the first thing, and again, we went from individual component to system level to trend. Then sensor accuracy verification, right? The sensors are telling me that I'm not within 45 to 55, but are they even right? Do we even know that over 8 years they were put in? Does anyone know how often you're supposed to change or calibrate a sensor? It's less than a year, right? Over 8 years, most of these are way out of calibration, right? So really going in with some sort of device that you could confirm if you're actually getting the good data, right? We always talk about garbage in, garbage out. You got to get good data, make sure those sensors are good. Functional testing, and then balancing verification. So I know we're at ACG. We are a consulting firm. We don't do balancing, so we subbed out that portion of the work. They worked for technically the museum, but again, part of the whole commissioning process, so that was great. So investigation phase, you do all your testing, now what? Right, you find all this good stuff, just hand over a report and say, good luck, or do you kind of stay around and make sure that everything's working? So that's where the implementation comes in. Right, we came up with a lot of issues, came up with a report, kind of went over it, sat down, had a bunch of meetings, talk about what our issues are, and now we're going to identify how we're going to fix those, right? What the corrective actions are for this particular project. And then verify the outcomes, right? So we're going to put everything in place and then kind of sit back. We talked about trending earlier, that you can't just see a point in time when you're doing the functional testing, but over the course of days, weeks, months, you want to make sure everything's working. That's where we're going to verify the outcome. So don't sit in front of a computer when you're doing testing, but you can when you're making sure the trends are okay. And then ultimately the handoff phase, and this is super critical also. The first and last, what we talk about in the investigation implementation phase is what people think of when you're talking about commissioning, but it's really the start and the finish that's going to make or break what's going to happen going forward, right? We could make sure that we leave it in a good place, but what's going to happen, even a year down the road. So luckily for us, we worked with the controls contractor that had a service contract with the museum, very familiar, going to be around a long time, and the operators themselves were working with us side by side to make sure any deficiencies or anything that we picked up during that phase, that going forward, they kind of understood what we were telling them. So with that, I'm going to turn it over to Molly.
Okay, so again, my name is Molly. I am a project engineer at JB&B, and this was kind of my baby for a couple of months. Really interesting case study. So what we're going to do now is I'm going to take you through the detailed tasks that we executed during the commissioning process to really get at that temperature and humidity control issue. Talk a little bit about what worked well for us. Hopefully you guys can take away something that you could use also in your processes moving forward. Right, so with that, we're going to jump right into the planning phase. The first thing that you want to do in the planning phase is pretty much get up to speed, right? What do I have in my facility? How is that facility being run? Essentially, you want to formulate the current facility requirements, or the CFR. Now, sometimes you're lucky and you walk into a building and you have a staff that's kind of familiar with commissioning and ongoing existing building commissioning, things like that, and they have a current facility requirements document formulated. Unfortunately, in this case, we didn't actually have that available to us when we arrived on site. In fact, commissioning hadn't taken place at all at the museum in the past over the course of the installation of the different phases. Right, so we're walking in cold. these guys have an idea of what they want. They certainly know they have a problem, which is that they're not maintaining their temperature and humidity. But we really needed to formulate, at the end of the day, what their requirements were for the facility on a day-to-day basis. Right, so that was a big part of getting started. Part of formulating those requirements was reviewing the existing documentation, or at least what was available to us. Again, Ryan mentioned that we did the design, which was immensely helpful because we did have access to a lot of the design documentation, which is great for understanding the design intent. There was a little bit of as-built documentation here and there from the museum, but not as much as we would have liked. So really, in addition to reviewing the engineer of record drawings, a big part of formulating those current facility requirements came from interviews with the staff. We spent a lot of time with the staff. We sat down with them to try to figure out, okay, I mean, you know you have a problem, but how are you dealing with that problem now, right? What exactly is your perception of that problem, and what are you looking for? So we took that information. We also sat with the BMS service provider who had been there for a long time, who was actually responsible for a lot of the install over the course of the 4 different phases, so he was a very knowledgeable person to sit down with. We performed an initial site walkthrough, and this was just a very high-level walk through the mechanical room, figure out what it is that we have, right? You know, you get on the phone, you have a meeting, yeah, we got 2 air handling units, but you don't really know what you have until you go into the mechanical room, you put eyes on it. Based on all of this information from the planning phase, we were able to develop the existing building commissioning plan, which laid out for the museum what we were going to do moving forward in the process, with the ultimate goal of addressing that temperature and humidity concern issue. So a couple things worth talking about in terms of challenges and limitations during the planning phase. You know, there are 2 worst cases in an existing building. Either you have an abundance of poorly organized information, or a complete lack of information, right? Those are kind of the 2 worst cases. On a project like this, you know, multiple phases, multiple different people who were ultimately responsible for putting together that as-built documentation or the submittals, whatever they were. You know, it was a challenge finding a lot of the stuff that we really could have used at the start. Like I said, there was some stuff here and there, but it was certainly a challenge getting started, just pulling information from over the course of the past 8 years. Operations and maintenance staff. So Ryan touched on this. It's really important that you get these guys involved as soon as possible, right? A lot of the time, operations and maintenance folks take a lot of pride in the systems that they take care of on a day-to-day basis. And if we're being honest, commissioning a lot of the time shines a light on some of the shortcomings of what the operations and maintenance staff is doing, right? So getting them involved early on, bringing them into the team, and letting them know that we're all trying to work towards the same goal was really important. And I think something that was really successful for us was convincing the operations and maintenance team that by correcting the issues, right, by being open and honest and transparent about where there were shortcomings potentially, you know, the correction of that would ultimately make their lives easier in the future, right? These guys don't want to deal with phone calls, you know, at 10 o'clock at night when they're home with their families about how temperature and humidity is out of range and can you go reset the air handling unit or whatever the situation may be. Equipment degradation. Okay, so air handling units phase 1. 2008, right? This is 2016 when we arrive on the site, and we're starting to look at this stuff. That's 8 years of time for that equipment to just naturally, in a sense, kind of fall out of its optimal operation, right? Wear and tear, especially if the operations and maintenance isn't as great as it possibly could be, which in this case, I think there certainly were some things that could have been improved upon. What you're seeing here is a drip pan underneath a coil inside the air handling unit. Obviously hasn't been cleaned in a while. We also found a lot of debris inside the coil itself, right? So maybe the drip pan doesn't get at the issue of temperature and humidity control, but if you have a coil that doesn't have a free flow of air, that could certainly have something to do with it, right? And this is another good example of equipment degradation over time. These are actually steam dispersion tubes inside the air handling unit used for humidification, right? And I don't know if you can quite see, but there's quite a bit of scale buildup on the nozzles for that dispersion tube. Right, so again, if you have you know, orifices that are sort of filled in and you're not able to get that steam out into the airstream, you're probably not going to be humidifying as well as you need to be. Right, so these were all some of the common challenges and limitations just getting started, walking in and understanding what we had before we really even started to apply, you know, testing and whatnot. So that essentially wraps up the planning phase, getting up to speed. Moving on to the investigation phase, this is sort of the meat and potatoes of the entire process. And I think there are a lot of different ways that you can conduct commissioning activities in the investigation phase, but we really focused in on these 4 different aspects: visual inspections, sensor accuracy, functional testing, of course, and then the balancing. So visual inspections, exactly what you would anticipate. We walked around the mechanical spaces, we went into the plenums, right? We popped ceiling tiles and went into the ceilings to put eyes on the variable air volume units. Just really spent some time interacting with the equipment on site. And we were able to pick up some things very early on without really even needing to look at the controls just yet. For example, on the left there, that's my colleague working with a backdraft damper on the return fans in the system. So you can see he's got them held open. That's what they're supposed to look like when the fan is running. Unfortunately, that's not what they looked like when the fan they were running. They were all kind of pointed down towards the floor, what I like to call droopy backdraft dampers. So that was ultimately really affecting the flow in the system, and was something that ultimately explained a lot about some of the issues these guys were having. We'll circle back to that later on. Same thing on the right here, your standard damper, isolation damper. Half the blades aren't actually opening, blocking the flow of air again, right? So just some easy, quick fixes, putting eyes on things and figuring out, all right, what's not working on a component level. Right, next up was sensor accuracy verification, and this one is really important. I feel like this is an easy one to forget, sensor accuracy verification. But as Ryan said, garbage in, garbage out. We're controlling our air handling units, humidification, dehumidification, temperature control, based on the aggregate of information about the climate inside the galleries. Right, so if you've got temperature and humidity sensors that are out of calibration or are reading incorrectly, your control operation is going to follow that bad data, right? So what we did, which was very successful actually, was go to every single controlling device in terms of temperature and humidity, and put our own calibrated test gauge next to that device and say, okay, I'm showing a temperature of 72 degrees. Mr. BMS man, what is my temperature saying at the BMS front end? Oh, well, it's saying 63. Okay, so that's a huge spread. Now we understand why some of the control is not right. It thinks that it needs to heat, for example. It's trying to get to 72, but we're already there, so we're overheating, in fact. We did use a calibrated temperature and humidity device. The calibration was really important to us just so that we knew, that we were getting the right stuff. And we had a pretty tight range for the galleries, plus minus 5% on the temperature, but plus minus 2% on the relative humidity. So anything that wasn't within those ranges was considered to be faulty, and we addressed later on. Here's some of the documentation that we used during the sensor accuracy verification. There's a lot of information on this, but really what's important are the colors, right? On the right-hand side, that's a pass or fail in terms of calibration. There's a lot of red there, right? There were a lot of things that failed. In fact, I think it was close to 37% at the end of the day. Controlling sensors in this facility were out of range or out of calibration, right? So some important takeaways there that definitely helped us explain some of the issues moving forward. After sensor accuracy verification, we moved into functional testing of the individual pieces of equipment. So that's your standard functional testing. We reviewed the sequence of operation and created project-specific forms that went through each aspect of the control for the air handling units. So these are pretty complex units that have a lot of capabilities, right, because of the nature of the project. We're talking humidification, dehumidification, temperature control, static pressure control, interlock, lead lag sequencing between the headered units, and of course safeties and alarms. So there was a lot to go through. We spent a lot of time testing the air handling units and the variable air volume boxes. We visited every single one with the BMS guy. And as you can see here, we found a lot of issues. Right, outside of the realm of the visual inspection, that doesn't look right, we found a lot of controls-related issues that needed to be addressed when comparing to the original design sequence of operation. All right, and the final part of our process for the investigation phase was a balancing verification. Again, very important, and this was where we really had the opportunity to look at the air distribution system as a whole. So we brought in a third-party person who came in, and we all sat down together and figured out, okay, where can we get the best data, the most useful data about the airflow in the distribution as a whole? And we came up with a number of different locations to take duct traverse readings at the mains, so the supply and return main coming off of the air handling units, but also at every major branch duct. And I think there aren't that many, but 8 branch ducts. So the balancer was there for 2 or 3 days, just taking duct traverse readings and gathering that information. And he handed over a report to us, and we actually took it upon ourselves to do a little bit of our own analysis. It's great to get a balancing report, it's kind of the raw data, but what we needed to do at that point was some airflow accounting, some basic, well, am I at least close? What I'm putting out, am I for the most part getting back? And as it turns out, the answer was no, especially on the return side, and I will go more into this later when we kind of get to the findings section. But we were quite short, actually, on the return side, which was made apparent by this balancing verification. We also did have the balancer go through and check K-factors on the VAV boxes, had him take some readings at the cross-flow sensors to make sure that the air was distributed correctly once you got downstream of the air handling unit. And again, the answer there was no. I mean, like Ryan said, you start with 15 VAVs and you cap a duct and then you come back, and who knows if you adjusted for the new stuff in the system, right? So this was a really useful exercise, not just sitting down with the balancer and taking the raw data, but also just doing some basic math. Am I getting out what I'm putting in? So here's some of the documentation that the balancer provided for us. You can see kind of where he took some of his readings. Interesting duct situation up there in the little box. 2 90-degree turns, you love to see that. Okay, so the findings of this entire process. Operations and maintenance was a little bit lacking in certain areas, and we understand that happens. There's a lot of different stuff in this particular facility. It's not all about these 4 galleries, so things slip through the cracks. But we did find some issues, and we did bring them to the attention of the operations and maintenance staff. Control schemes for the air handling units had changed drastically over time when we really went back and looked at it, which is somewhat typical for an existing building, especially one that's been in operation, well, this building's been in operation for a very long time, but this system for 8 years. So, you make a tweak here, you change something there on account of a hot-cold call. Next thing you know, your variable air volume system is a constant volume system, and you're changing discharge air temperature all the time. It happens, right? So we went in and we worked with the BMS guy, just made sure that we got some of those control schemes back to where they needed to be for design. 37% of JB&B verified sensors were out of calibration, right? So that's a lot. Again, we already talked about that. Garbage in, garbage out. 58%, this one really blew my mind, 58% of return air was missing from the return side of the system. And if you think back to that photograph of the droopy backdraft damper, that in collaboration with some other partially closed dampers and some interesting duct plenum arrangements was ultimately responsible for that quote-unquote loss of air, right? Things were just having a hard time getting back to where it needed to be. And then finally, 2,300 CFM of air was distributed incorrectly at the VAV boxes, probably on account of the different phases happening at different times. So those were our findings of the investigation phase. Ultimately, we felt like we found a lot. It was a really good exercise in systematically going through each piece of equipment, understanding the system, and addressing the issue at hand. So cool, we found lots of cool stuff, but now what do you do? Right, that's where we step into the implementation phase. So, we got to tell these guys what they need to do to correct the problem, right? To address some of the issues that we found, and ultimately how it's going to get back at our original issue of temperature and humidity control. We got to implement those corrective actions, and then of course verify that they did what they were supposed to do. Right? So simple retrocommissioning measures. Again, it wasn't with a focus on energy savings or anything like that. It was just basic, you guys should really probably fix this kind of stuff. Worked with the BMS service provider just to get that air handling unit, those VAV boxes, back to where they needed to be. They were really operating in places where they weren't designed to operate, right? So you want to get your best operation out of your equipment, you should really follow that sequence of operation as much as possible. as a step further, sure, we put a lot of stuff back to the way it needed to be, but we also spent a fair amount of time optimizing, and in certain cases, we made improvements, just based on the current facility requirements that we had formulated at the beginning of the project. A big part was tuning PID loops, right? So that, if you think back to that trend of relative humidity that Ryan showed you in the beginning, it's very chaotic and noisy, right? A lot of that is just poor tuning of the PID loop, right? So we sat down with the BMS service contractor provider, and we pretty much were just tweaking. For a couple of days, we tweaked parameters here and there, and ultimately tried to get those loops to where they needed to be. Of course, we insisted that they recalibrate or replace faulty sensors. There was a certain range where we felt that we could do a recalibration instead of a full replacement. But yeah, paramount importance to make sure that those sensors were corrected so that you get the best data. And then if we had the balancer, while he was on site, he did his verification. We did our analysis, and then we had him come back and make adjustments to the system so that the system was balanced correctly at the end of the project. The final step in this whole process was to create some implementation plans, and I'll talk a little bit more about what we did for the operations team in the handoff phase in a minute here. But it was important to us that we not walk away and say, okay, well, good luck, hope it works out for you. We wanted to give these guys the tools to actually continue to maintain the systems the way they needed to be maintained, especially considering that awesome painting of Snoop Dogg. Personally, I didn't want to see anything happen to that, so this was our starting point. 45 to 55% relative humidity is where we want to be. We're outside of that range, of course. This is the start of the project. This is just kind of a scaled view because we're going to look at a couple of more trends here that are going to be closer to this scale, right? But we're not even on the page. We're just completely out of the range of where we need to be, right? And you don't want to see swings in your relative humidity of, 5 percentage points over the course of less than an hour. It's too much. So that's May 12th, that's the beginning of our project, right? By May 20th, things are starting to get a little bit better, right? You can see that they were very messy, prior to making some changes, correcting some things, focusing on some control schemes at the air handling units. Still a little bit noisy, but at least we're within that 45 to 55% range. So we're making progress. And then here we are towards the end of our project, June 6th. We're well within that range, right? So our dotted lines are off the page because we're doing so good. And this was really great to see, and the conservation staff was very relieved. What a lot of people don't actually know is that in a conservation department, you have to prove that you can maintain your climate. Otherwise, people aren't going to give you art, right? Makes sense. So this gave everybody the warm and fuzzies for sure. 47 to 52, a couple of things here and there, a couple isolated events that caused a spike. But overall, doing really well in the realm of relative humidity. So for the handoff phase, just want to make sure these guys can maintain that nice trend. So we, of course, developed a final existing building commissioning plan for these guys so that the information of everything that we did was available to them. In our EBCx final report, we do include every test script. And that was important because the operators now can go back to those, and if they want to do an ongoing commissioning type deal, they have the opportunity to go through our forms that are tailored specifically to their systems, and do the functional testing themselves, although we'd rather have them call us. And then, of course, we did some preventative maintenance items and plans for these guys just to make it easy for them, right? For whatever reason, they hadn't gotten around to a formal document that said you need to replace the filters every 6 months. So we did that for them, right? We put it all in a place and we issued it so they couldn't say they didn't have it. So in conclusion, right, the team aspect of the existing building commissioning process was really important. But if you do things systematically and you involve the right people, definitely take advantage of monitoring and trending, you can ultimately really apply a very successful existing building commissioning process to whatever kind of project you may have. In this case, it was particularly critical just because of the nature of the museum, the art in the museum. But I think in general, this process can really apply to any kind of project. And then, finally, I just want to say that preventative maintenance plans, and we did do a lessons learned exercise with the client after the fact, was an important part of just making sure that moving forward, they were going to be able to keep things where they needed to be. So with that, I just want to say there is a more detailed account of this whole project with a little bit more technicality that was just published recently in Papyrus, written by Ryan and myself. You can certainly read that if you have more questions or would like more information about this particular case study. It's available on our thought leadership page at the JB&B website. So again, I just want to say thank you for being here with us this morning. Hopefully you got something useful out of our presentation. Our contact information are here, so if you have any other questions, please feel free to reach out. And at this point, I think we're done.